Hi everyone, this is Miss Gavin. I'm one of the Algebra 1 teachers at Salem Middle School. This is our first set of focus notes, and so I want to go over a few things before we start the notes. If you have access to a printer at home, you are more than welcome to print this document off and follow along as you're watching the video by taking your own notes. If you don't have a printer at home, that's totally fine, because what you can do is you can just open up the document and type as you're watching the video. So having those two tabs open and follow along and save it as it is, because it is important for you to have this information, your own copy of it. In these notes, we are going to be discussing the real number system. At the end of the notes, you'll be able to say, I can describe the relationships between the subsets of the real number system. That's our learning target. Our essential question for these set of notes is, what is the difference? What is the difference between the subsets in the real number system? So at first you're probably wondering, what are real numbers? Real numbers are all rational and irrational numbers. So this is kind of like an umbrella term that we use. And then now we're going to divide it up into those two sections. So irrational and rational. We're going to talk a little bit about each of those. Irrational numbers are decimals that never terminate. And a synonym for terminate is end. Never terminate. I'm going to put in parentheses, end. And have no repeating pattern. So we have a few examples below. Pi is an example, the square root of 3, and then we have a few other examples listed below. Okay, so now we're going to move on to rational numbers, and all numbers that can be written as a fraction are rational numbers. So these are decimals that terminate or have repetition. And a helpful way for you to learn this is that repeating decimals, that starts with an R, repeating, and then rational also starts with an R. And so we've listed some of those examples below. As you can see, these all can be written as fractions, and the square root of 49, that's going to give us 7. So that's why that works. Within rational numbers, we're going to have 3 different subsets, and these are integers, whole numbers, and natural numbers. And so we're going to talk about those, and we're kind of working our way down. We're going to have a Venn diagram that you all are going to be able to see for all those visual people out there in order to understand the real number system just a little bit better. All right, so when talking about integers, we are discussing positive and negative numbers, and I'm just going to use that symbol, numbers on a number line. Okay, so when thinking of integers, you should be thinking of the number line. Whole numbers, so whole numbers, think of that whole, think of HOL as well. So kind of, and that's, a whole is going to give you the shape of 0. So this is all numbers 0, and up. And then natural numbers are your counting numbers, so that just excludes 0. So natural numbers are all numbers 1 and up. And also just to note how these integers, whole numbers, natural numbers are different from other rational numbers is that these are not fractions or decimals. The one exception to that would be if you had a fraction and when simplifying it, it would create an integer or a whole number. So for example, -4/2, whenever you simplify that, you're going to get -2. So that itself would be an integer. However, that's because you didn't simplify all of the way. All right, y'all, so this is the visual representation that I was talking about earlier. This is how we can organize the real number system in a diagram. So as you can see, the real numbers, that's an umbrella term for our numbers. And then we are going to go ahead and divide them up into two different sections, the rational numbers and the irrational numbers. Then within rational numbers, we have three other subsets. Okay, and it's a little natural for you to feel like, oh, how am I going to remember which ones are which? So we have a mnemonic that's going to help you memorize which ones are which, and we're going to start with the smallest subset and go out. So we're going to work from natural to whole to integers and to rational numbers. So I want you to make sure that you're taking note of this. So the mnemonic that we're going to use is never walk in rain. And so that'll help you remember those subsets within rational numbers. So again, we're working from the smallest. So never stands for natural, walk is whole, in is integers, and rain are rational numbers. Hopefully that can help you out a little bit. All right, so now we're going to put what we learned about the real number system to use, and we're going to do this by being given some numbers and marking X's next to the subsets in which these numbers belong to. So we're going to want to refer to our definitions of the subsets within the real number system, okay? So we are given 0 and 25 hundredths. That is a decimal, and it is a decimal that ends. And so because of that, we are going to mark it as a rational number. It is not an integer because it is not a number on the number line. And so since it's not an integer, we also know that then it's not a whole number and it's not a natural number. All right. Our next one is the square root of 3. If you were to plug that into the calculator, you would get 1.73200508 and continued. Because of that, this is a number that does not end and it does not have a repeating pattern as well. And so because of this, it is an irrational number, and so it cannot be in any of the other subsets. Next, we have 0. 0 is a number that ends, so it is a rational number. Let me use my pen real quick. It's a rational number. It's also on the number line, so it is an integer, and it is also a whole number. However, it is not a natural number. When you hear natural numbers, I want you to think of when you learn to count as a little kid, and you typically don't start with 0. All right, next we have the square root of 64, which we know gives us 8. 8 is a rational number because it ends. It's on the number line, so it is an integer. It is a whole number, and it is also a natural number. I just want to point out something real quick, if something is a natural number, then that means that it must be in all of these other categories, these 3 other subsets. If something is a whole number, then it must be in these 2 subsets. And for example, we don't have one specific to this, but if something is an integer, then it must belong in the rational. And we can kind of see this in the diagram above as well. Our next number that we have is 7 29/100ths repeated. And again, we mentioned earlier, repeating decimals, these are rational numbers. So this is going to fall in that rational numbers subset. However, it is not on the number line, therefore it's not an integer, and since it's not an integer, it cannot be a whole number or a natural number. All right, next we have -6. -6 ends, and so that's a rational number. -6 is on the number line, so it's an integer. It is not a whole number or a natural number. Okay, next we have 3 14/100ths. This looks similar to pi, but it is not. It ends, and so because of that, it's a rational number, and that's all it is. Next we have -2 1/4. Since this is written as a fraction, then we know that this is a rational number. However, fractions do not appear on the number line, so this is not an integer, and therefore it is nothing else on the right. Okay, then we have negative square root of 16, which translates into, that's going to simplify into -4. And so that is a rational number. That is an integer. It appears on the number line, but it is not any of the other categories. Now we have 0.1256, and it looks like it keeps on going. Since it keeps on going, since it doesn't terminate, and there isn't a repeating pattern, this is an irrational number and therefore doesn't fall in any of the other subsets. Now let's look at the next one. This one is a little different. We have 0.3434. It looks like it continues, but it also has a repeating pattern. So again, let's look at our helpful hint from the front page of the notes. And if it's a repeating decimal, then it's a rational number. And so this is going to fall in the rational number subset, but none of the other subsets to the right because it does not fall on the number line. And then lastly, we have pi, which is 3.1415, and I could just keep on going. And since I could keep on going and there is no pattern with this decimal, then it is an irrational number. All right, so your teacher is going to discuss what we're going to do with the summaries from here on out. So look forward to information from your teacher about that. Thanks for paying attention to the video. I hope you enjoyed.